So if we didn't have this plus 3 here, then it would be like multiplying monomials like we did before. But because we have this plus 3, this becomes a polynomial. And now we're multiplying 6v times a polynomial. All we have to do here is distribute the 6v to both terms in the parentheses, or however many terms is in the parentheses. You just have to distribute the 6v to every term. When we multiply, it's like we're multiplying, or we use the same rules that we did when we multiplied monomials. So we multiply coefficients first, 6 times 2 to get 12. And v times v, when we multiply variables that have the same base, we add the exponents. And right now, the exponents on both of those v's are just 1. So when we add the exponents, we get v squared. And then 6v times 3 is 18v. You just multiply the 6 times 3 and the v just stays. That's it. That's our answer. That's it. Well, that's it on this one. But they don't get much more complicated than this. Happy day. Yeah. Example 2. (2n plus 2 times 6n plus 1). This one, we're multiplying 2 binomials. So they're just, all that means is this is a polynomial that has 2 terms. They call that a binomial. And when you're multiplying 2 binomials, we have kind of a trick to remembering how to multiply called FOIL.
FOIL, I learned it 3 days ago.
All it is just an acronym to help you know which terms to multiply. The F means the first term in each binomial, so 2n times 6n. Outside is the 2 outside terms, which would be 2n and 1. I is the 2 inside terms, so 2 and 6n. And L is the last term, so 2 and 1. Now, you can use FOIL to help you remember which terms to multiply, or you can just think of it as distribution because that's what it is. You're distributing 2n to both terms in the other set of parentheses, and then you're distributing 2 to both terms in the other set of parentheses. It's that easy. Okay, so let's multiply. 2n times 6n. 2 times 6 is 12. N times n is n squared. And then 2n times 1 is 2n. 2 times 6n is 12n. And 2 times 1 is 2. After we multiply, all that's left to do is to add like terms or combine like terms. So just really quick, let's have a reminder of what like terms are. Like terms have the same variables. And the same exponents on those variables. It has to have both of those things to be like terms, the same variables and the same exponents on those variables. So even though both of these first 2 terms have n, one has an exponent of 2 and the other one has an exponent of 1. So those are not like terms. The only like terms we have are 2n and 12n. So we'll add them up. Everything else is going to stay the same. 12n squared And then when we add 2n plus 12n, we get 14n plus 2. Okay, be careful here. A lot of people have the tendency to, when you add these like terms, some people will add 2 plus 12 to get 14, and then they'll also add the exponents on the variable and put n squared instead of n. That's only when you're multiplying two terms, you add the exponents. When you're adding like terms, you're basically adding groups of the same thing. Like I've used apples as an example a million times, but it's like you're adding 2 apples plus 12 apples. You get 14 apples. You don't get 14 apples squared. Okay, that's it. We're done with example 2. We got one more. Four a plus 2 times 6a squared minus a plus 2. Okay, so we can't use FOIL because we're not multiplying two binomials. This second polynomial has 3 terms. So we're going to use that second method that I showed you in example 2. It's just the distributive property. You take every term in the first set of parentheses and distribute it to every term in the second polynomial. So we're going to take 4a and distribute it to all 3 terms in the second polynomial. Then we'll do the same thing with this 2. It gets distributed to all 3 terms in the second polynomial. You would do that no matter how many terms are in either one of the polynomials. You'll do it the same way. Okay, so let's multiply. 4a times 6a squared. 4a times 6a squared. 4 times 6 is 24. A times a squared is a cubed when you add the exponents. 4a times negative a, careful with your signs here. 4a times negative a is negative 4 because you're multiplying 4 times negative 1. And then a times a gives us a squared. So negative 4a squared. 4a times positive 2 is positive 8a. Now we distribute the 2. 2 times 6a squared is 12a squared. 2 times negative a is negative 2a. And 2 times 2 is 4. All right, last thing is to combine like terms. So we've got an a cubed. We don't have any other a cubes to combine with it. A squared, we do have some like terms that are a squared. And then just a to the first power. We have 8a and negative 2a. Those are our like terms that we can combine. So we get 24a cubed. And then we have negative 4a squared plus 12a squared gives us a positive 8a squared. Then 8a minus 2a is 6a plus 4. That's it. Anybody have questions on these 3 examples? All right, y'all got, why can't I talk today? Y'all give me just a few minutes, a couple of seconds actually, to get this assignment, your practice problems posted, and then I'll let you know if you can leave the Zoom.